Today we're going to be talking about relations and functions. A relation is a set of ordered pairs. So for instance, in this table it says generate ordered pairs for the function y equals x plus 3 for x is equal to negative 2, negative 1, 0, 1, and 2. And then we want to graph the ordered pairs. So what we're going to do is first of all write down the function for y equals x plus 3. And we are going to plug in the ordered pairs negative 2, negative 1, 0. To pull this down. 1 and 2. And we're just going to plug them in place of y equals x plus 3. Well, in place of x we have negative 2 plus, and then plus 3, so that gives us 1. Then we have in place of x negative 1 plus 3, which gives us 2. Then 0 plus 3, which gives us 3. 1 plus 3, which gives us 4. And 2 plus 3, which gives us 5. Alright, so now what we want to do is we want to graph those ordered pairs. So I'm going to see if I can find a little spot to put a graph here. You can see I've placed this graph off to the side. So we are going to graph the ordered pairs. I'm just going to write them over here. Negative 2, comma 1. Negative 1, comma 2. 0, 3. 1, 4. And 2, 5. So let's go ahead and graph those. We go to the left 2 and up 1. To the left 1 and up 2. We stay at 0 and go up 3, right 1 up 4, and right 2 and up 5. And you can see that we do get a straight line. Now I didn't say to connect them, it said just to graph the ordered pairs. Now let's continue on. Representations of relations. Again, remember, let's go back to what the definition of relation is. It's just a set of ordered pairs, like it says here at the top. So that's what we had here in this graph. Representations of relations. You can make a table. Like here's track scoring results. If you place in first place, you have to have earned 5 points. In second place, you earn 3 points. Third place, 2 points. And in fourth place, 1 point. Here is a graph of that same information that we made with the place going on the horizontal axis and the points that you earned on the vertical axis. And actually, this one should have been up here. Okay. Or actually, let's change something else. It should have been a 4 in the table. There we go. That makes more sense. Okay, so if you placed in first place, you scored 4 points, second place 3 points, third place 2 points, and fourth place 1 point. The other thing we can do is, and again this should be a 4, is we can look at a mapping diagram. First place has 4 points, second 3 points, third place 2, fourth place 1. You can see how the how one coordinate, the place value, in this case this is your x, is connected to the y. Okay? So one variable is connected to the other in a mapping diagram. These all represent relations. Let's move on to the next page. It says express the relation 2, 3, 4, 7, 6, 8 as a table, as a graph, and as a mapping diagram. So first of all, let's see if we can make a table of this information. So here's x and y. And the values for x, the x values, if you look at your points, are 2, 4, and 6. The y values are 3, 7, and 8. So it takes care of the 0.23, 47, and 68. Now, if we want to express this information as a graph, let's do that. You can see now I've placed my graph up here, my grid, and so let's basically just graph those points. We're graphing the points 2, 3, so to the right 2, up 3, 4, 7, to the right 4, and up 7, and then 6, 8. So we go to the right 6, and up 8. So we've represented the relation as a graph, and now let's do this as a mapping diagram. So basically we're just going to create these ovals, and we're going to list the x values in the first one, 2, 4, and 6. And 2 is associated with the y value of 3, so we'll write 3 in the second one and draw an arrow from 2 to 3. 4 is associated with 7, so we write 7 in the second oval, draw an arrow from 4 to 7. And 8 is associated with 6, so we draw an arrow from 6 to 8. And there is your mapping diagram. Moving on to the next page, we're looking at some vocabulary. Domain means the set of first coordinates or x values of the ordered pairs. Range is the set of second coordinates or y values of the ordered pairs. So a domain are your x's, range would be your y's. Let's take a look at this example here. I'm going to just scroll down this page so we can see it. Here is a graph which shows the scoring for a track meet. No, I'm sorry. No, that is the next example. Let's go back up. Going back to our example, I'm sorry, on the track meet scoring. The domain was the place that you could have. If we went back to that first diagram, you could place first, second, third, or fourth, so that was your x value. Your y value was the number of points that you could earn. So if you remember correctly, we actually said that 5 should have been a 4. You earned 4 points to place in first place, 3 points to be in second, 2 points to be in third place, and 1 point to be in fourth place. Now, this is a different example. Give the domain and range of this relation. So what we want to do is see what the x values are. Now, it looks like these increments go up by 1s. The x values range, let's see, this first x value on our graph, if I can get the pen to work. So the x value, or the first point, is the point, let's see, 2, 9. And the point over here to the far right, where everything seems to end, where the line seems to end, is the point 7, 1. So if you look at your x values, it looks like they range all the way from 2 up to 7. So the way we write that is for our domain, we put x in the middle, and we've done this before with compound inequalities. We say that x ranges from 1 all the way up to 7. And we should put a less than or equal sign in between because it can include those values. The range, well, that's the height of the function. So it goes from 1 all the way up to 9. And so there is your domain and range. Now, next, here we have a vocabulary word, function. I've used that word, but let's formally define it. A special type of relation that pairs each domain value with exactly one range value. Note, a graph is a function if it passes the vertical line test. Now, just to give you an example of what a vertical line test is, let's say that you have a graph that looks like this here. I want to know if it's a function. It's a function if I can pass a vertical line through it at any point and it only hits in one particular point. I did not mean to have this piece on the end here. So if you can pass a vertical line, let's see if I can just draw one here, through this at any point and it hits the function at only one point, it would be, or it hits the line at only one point, it would be a function. And that is the case here. We'll see more examples of that in class. Let's go on to the next page. Give the domain and range of each relation. Tell whether the relation is a function and explain. Now, one thing to note is that if x values repeat themselves, so if x values repeat themselves, it is not a function. That's one particular rule that you can use to decide if it's a function or not. So, for instance, in this case, the domain, that's the x values. The domain is 3, 5, 4, and the 3 repeats itself. So you don't have to write it down twice, but it does repeat. The range, those are the y values. That's -2, -1, 0, and 1. Now, because those x's repeated themselves, see how we had a 3 in the first ordered pair and a 3 in a second ordered pair, we are going to say this is not a function because the x values repeated themselves. Let's take a look at this next one. The x values are -4, -8, 4, and 5. Now let's think about it. Do the x values repeat themselves? Well, this gives us the ordered pair -4, which goes to 2, -8, which goes to 2, 4, which goes to 1, and 5, which goes to 1. Now, do the x values repeat themselves? No, they don't. So this is a function. X's do not repeat. Excuse me. Next, we want to know if this figure is a function. Well, does it pass the vertical line test? Can you put a vertical line through it and not have it hit in more than 2 points? Well, no. Look at this. This vertical line hits in 2 points. So, no, not a function. Doesn't pass vertical line test. And the very last one, is this a function? Well, can you put a vertical line through it at any point and have it only touch the function once? Yes. So our reason being, it is a function because it passes the vertical line test. Thank you so much for joining me today.